Hello, welcome to the project demo for Team TBD9. Our project is called Traffic Noise Frequency Assessment Application for Adverse Health Risk in Property Residents. Our team members are Syed Assad Zahidi, Sydney Cole, Juan Rodriguez, Yaping Yang, and Deontay Barnes.
For our elevator pitch, which is our project recap, we want to summarize the aims and objectives of our project. In this project, we aim to deliver an application that can be used by real estate developers to record nearby traffic noise at residential development sites to assess if building residential property at a given location due to the frequency of traffic noise in the immediate area will pose excess risks for inhabitants for the following illnesses: ischemic heart disease, for which the unhealthy range of traffic noise is between 950 Hz and 8,421 Hz; hypertension, for which the unhealthy range of traffic noise is between 1900 Hz and 8,421 Hz; and depression, for which the unhealthy range of traffic noise is between 950 Hz and 1900 Hz. The application also has a landing page, which includes a summary of some of these aims and objectives, as well as target frequency ranges for the three illnesses.
The one change that we had made to this application is that we had added in an extra deliverable to its scope, which would allow the application to play back recorded audio after our proposal was already submitted, and this extra deliverable was taking away time from deliverables that were stated in our proposal. After receiving feedback from Team TBD 8, we ended up getting rid of this extra deliverable so we could focus on delivering what we had promised in our project proposal.
For a reflection of this project, we have learned that adjusting sound frequency ranges for a reliable confidence interval, such as the 95% confidence interval that we have used for the frequency values that our application tests for, prevents the application from missing edge cases. Edge cases where an Android microphone may not be able to pick up exactly the correct frequency of the input audio noise, if it is out of range by a few hertz due to recording inaccuracies especially. We also learned that multiple illnesses that we are checking the health risk for in our application will overlap with one another. So we had to build an application to show multiple names of illnesses on the user interface at once. We achieved our goals in this project. Since we delivered an application that can assess traffic noise frequency by receiving an audio input through the built-in microphone of an Android phone and compute the audio frequency of the input noise, then match it to one or more illnesses and return the frequency value in Hertz, along with the name of the illnesses that it poses excess risk for, to the user interface.
Here is our application usability demo. I'm showcasing the application using an Android Google Pixel 4 XL emulator in Android Studio. The emulator is configured to treat the default microphone of my PC as the built-in microphone of the Android phone. I have confirmed with the course instructor, Clint Ziegler, that demoing the application using this emulator is fine. This application is built in Java and utilizes the Tarzos DSP pitch detection library, which is cited at the end of this presentation, to compute noise frequency from audio input. The application launches on the landing page that you are looking at. The text on this page provides usability information about the application that has already been covered in this presentation. For the sake of time, we do not need to read through this, since what is stated on this page has already been covered in this demo. When I click on the Get Started button on this page, it leads me to the listening page where the phone's built-in mic will start to pick up nearby audio. I will play 3 noise clips that I found on YouTube, which will be cited in the references that are shown at the end of this presentation. You will not be able to hear the audio clips in this recording since I am using headphones cupped over the default microphone for audio inputs, but I will let you know when I am playing which audio clip. When I play the audio from the 750 Hz clip into the default microphone, this page tells me that there is no excess risk for any of the illnesses, since this frequency doesn't fall in the range for any of the illnesses that we are testing for. When I play the 1500 Hz audio, the screen shows a value around the frequencies that we expect and informs me that this frequency poses risks for ischemic heart disease and depression, which is correct based on the ranges that we are testing for. When I play the 7500 Hz audio, the screen informs me that there is adverse risk for ischemic heart disease and hypertension, which is also correct based on the ranges that we are testing for.
And here are our references.